All right, so on November 20th, we were supposed to talk about a couple things in class, but because 62% of my students didn't come to school, today's lecture is going to be recorded, and then you will get a chance to watch it later. Last time I didn't show up in the camera at all. Today I will show up on screen because I know how much you love looking at me because I'm your favorite chemistry teacher. So here we go. Today, I guess for those of you that need an essential question for your notes for Avid, it would be something like this. What is an ion? So again, we've been talking about atoms, how we've arranged the periodic table, all of these things. And the crazy thing about chemistry, it all wraps together. There's no one individual thing that is like the way to look at it. It all builds on each other. And so today, when we look at what is an ion, we have to think through the process of how did we come up with the periodic table? What do we know about protons? What do we know about neutrons? What do we know about electrons? So a neutral atom is what we've been talking about for everything else. Everything is a neutral atom until it becomes an ion. So essentially, the easiest way to say this is an ion is a charged particle. So we have to be careful. We can't say just an atom, but it's an atom or a group of atoms that has either gained or lost electrons. How many electrons it has gained or lost will determine the actual charge on the ion. So again, this is one of the things that becomes kind of backwards about chemistry. Normally when we think about gaining and losing, you think of gaining as being positive and negative as being lost, right? So when we gain something, it's positive, I'm getting stuff. That's the exact opposite in this case. Because what we're looking at now is these little particles called electrons. And electrons are negatively charged. So if I gain something that's negative, what's going to happen to my charge? It becomes more negative. If I lose something that's negative, I become more positive. Atoms continue to have protons. Protons are positive pieces. And so if I'm losing electrons, I'm becoming more positive because I have all the plus parts, but I've lost some of my negative parts. If I gain electrons, I'm getting more of these negative pieces, but I'm not doing anything with the protons. The number of positive pieces remains constant. So to look at this in an example, I draw a picture here. I hope I can see it. Let me go adjust the camera just to make sure. So what you see here, and in fact, you know what? Somebody else told me about this. The lights is always a good thing. With better lighting, you'll see it better. So a charged particle means it's gained or lost. So we have here, on the left, you have a lithium atom. Notice that there are the three black dots in the middle. Hold on a second. The three black dots in the middle are going to represent protons. So lithium being number 3 on the periodic table, these are the 3 protons. And surrounding it are these 3 dots. Those would be the 3 electrons. So since the number of protons and the number of electrons is the same, that would be a neutral lithium atom. But if one of these electrons, let's just pretend that this electron, that is a really big line. I do not want it that big. This little electron flies away. And now we have this picture. So we have 3 positive pieces, 3 protons, and we have 2 negative pieces, 2 electrons. So what we're saying is one of the electrons has lost. This means I have 3 positive pieces and 2 negative pieces, and the total charge on this whole thing now is a lithium ion that is lithium, and we just write the plus. You don't need to write the +1 because since, can you see that? I can't even see where I'm writing on the screen. Oh my gosh. So, what is happening? Oh, it's backwards. You guys didn't realize. It's a mirror image. I'm looking at the wrong side. So over here, we've got this lithium ion. It's a lithium with a +1 charge. And so what ends up happening is when we lose one negative piece, it becomes more positive. If we gain electrons, it would become more negative. So last time we talked about these electron configurations. And in the electron configurations, we talked about losing and gaining. Well, we didn't talk about that yet. I forgot that this was written here. Metals are going to lose electrons. By losing electrons, we're losing negative pieces. They become more positive. The non-metals, which are on the right-hand side of the periodic table, they're going to gain electrons. And the reason for this is something that we have found, chemists over the course of the years have found that there is stability in full valence electron shells. That is known as the octet rule, because everything except for the first 5 elements is going to want to have what we call 8 valence electrons. So 8 being an octet, you might recognize that prefix oc, like octagon, or an octopus means 8. So an octet means that there are 8 valence electrons. So when we look at this from the electron configurations that we've been talking about, I looked at just the 3rd period on the periodic table. So sodium is number 11, number 12, number 13, 14, 15, 16, 17, 18. These are the elements on the periodic table, and what we're looking at is their electron configurations. So all of them are 1s2, 2s2, 2p6, 3s1. So energy level 3, 1 electron. Energy level 3, s sublevel, 2 electrons. That one gets full, we have the 3rd, and the 4th, and the 5th, and the 6th, and the 7th, and the 8th. And notice that there are 8 when we get to argon. All of these, sodium had 8 in the 2nd energy level. 8 in the 2nd energy level. 8, 8. All of these have 8 in the outer energy level. So what ends up happening is we can use this electron configuration idea in order to help us figure out what the charge is going to be on the ion. So again, metals want to lose electrons. If this 1 electron were to fly away, it would have 8 in its valence electron shell. That's 2s would then have 8. If magnesium were to lose 2, it would have 8. If aluminum lost 3, it would have 8. So what ends up happening is the charges match how many electrons they have lost. So sodium lost 1, it's a plus charge. We say it's plus 1. Sodium is plus. We don't usually say the 1s because that's kind of redundant. But magnesium is plus 2 because it has lost these 2 valence electrons. What do you think aluminum is going to do? There's 3 electrons, so it's going to lose 3 electrons. That's not what I wanted it to do. 3 electrons. But now when we get to silicon, something weird happens. Let's go the other direction. That's, again, argon now has 8, right? So argon is not going to form an ion. It's just going to be argon. I put the question mark there like, what just happened? What is happening here? That's what I wanted. So argon is going to be no charge. It's just argon because it has its 8, and we know that the noble gases don't want to gain or lose electrons, so that's what they're going to look like. Chlorine is going to be a -1. Notice that it has 7. If it could gain 1 more electron, it will look like argon. It will have 8 in that outer shell, and it will be happy, it will be content, it will have its octet filled. The same thing will be true with sulfur. If it gains 2, so it's going to be a -2 charge. Phosphorus would be, very good, -3. And that leaves us with silicon, which becomes really crazy. Silicon in that whole group, so carbon, silicon, germanium, those 3 elements that are in group 15 on the periodic table, they do some weird things. Because what's going to be easier? Is it easier to lose 4 electrons to look like sodium? Or not sodium, actually, to look like neon? Or is it going to be easier to gain 4 to look like argon? So again, it's both. Sometimes it's easier to gain 4, sometimes it's easier to lose 4. Do you see why we say that silicon and carbon are considered metalloids? Sometimes they gain electrons to look like a nonmetal, sometimes they lose electrons to look like a nonmetal. So this is the crazy part. If we were to look at a periodic table, it is really super simple to see that if you count from left to right, you will see their simple ionic charges. Those in group 1 become +1, including hydrogen. Like hydrogen is going to be a +1. Helium, remember we plucked helium off over here and moved it over here for a while? So helium is actually not a +2 because it's a noble gas. It doesn't gain or lose electrons because it doesn't form ionic charges. So group 1 are going to be +1. Group 2 are going to be +2. Group 13 are +3. Then notice that this one we wrote plus or -4. With the exception of these 4 elements down here in the bottom, they act more like metals, and so they have what we call variable charges. We're going to skip over all of the transition metals because they do some weird things. But then -3, -2, -1, and the noble gases are 0. So if you think about this easily, the S sublevel is either going to lose 1 or lose 2 electrons. The P These are going to lose 3. It could either gain or lose 4. These are going to gain 3, gain 2, gain 1 electrons. And so the charges on these ions match what they have gained or lost in terms of electrons. So, that's not what I wanted. Can you tell that I want another, there we go. So, for example, the way we write this, we already said before that it's lithium with a plus, or it's sulfur with a -2, or it's chlorine with a -1. We say that these are their charges, but the way that we name them and what we call them is going to change. We're going to go into a lot more detail about how to name things when we come back from Thanksgiving, but you need a little bit of information. So this is called a lithium ion. It has 1 less electron. This is a sulfur ion. It has 2 extra electrons. It has gained 2 electrons. This is a chlorine ion. We actually call it chloride. You may have heard of that before, like sodium chloride. Chlorides are not chlorines, and they have gained 1 extra electron. So throughout all of this, what you need to be aware of is ions form by gaining and losing electrons, and then their charge is based on how many electrons they have either gained or lost. Like I said, there's going to be a lot more to this when we come back from Thanksgiving break. For right now, you need this bit of information, and we'll move on from here in class on Friday.